Welcome to KlassPM. Today we are going to discuss about chemical reactions and equations. In this chapter, you already studied about temporary, permanent, natural, man-made changes. In your previous classes, you already learned about changes like temporary, permanent, natural and man-made changes. If you see these changes, we can categorize these changes into two main categories. That is physical changes and chemical changes. In this chapter, we discuss about chemical changes and express them in the form of chemical equations. Let us see these changes. If you observe in daily life, that is, coal is burnt, food gets digested in our body, iron nails is exposed to humid atmosphere for a long time, we respire, milk is converted into curd, water is added to quicklime, crackers are burnt. So if you observe all these things, what changes do you notice? Are they physical changes or chemical changes? Are they temporary changes or permanent changes? In all above cases, the nature of original substance would be changed. It means that the nature of original substance is changed, and then if new substances are formed with properties completely unlike those of the original substances, we say a chemical change has taken place. What we understood here? Okay, original substance undi. Original substance completely changed its properties and new substance is formed. Then what we can say that changes is a chemical change. How do we know a chemical reaction has taken place? So to understand that whether the chemical reaction has taken place or not, let us observe some activity. Take about 1 gram of quicklime, that is also called as calcium oxide, in a beaker. Add 10 ml of water to that. After some time, if you touch the beaker with your fingers, what you can observe here? What do you notice? We can notice that the beaker is heat. What does it mean? It means that in the reaction, heat is released. The calcium oxide reacts with water and in the process of that, heat energy is released. Calcium oxide dissolves in water, producing colorless solution. Let us test the nature of the solution with litmus paper. When you test with the litmus paper, what it indicates? What is the nature of solution? If you take a red litmus paper, it turns to blue when dipped into the solution. What does it mean? Because of that red litmus paper transformed into blue litmus paper, we can say that the solution is basic solution. Let us see another activity to understand in a better way. Take about 100 ml of water in a beaker and dissolve a small quantity of sodium sulfate, that is Na2SO4. What is that? Na2SO4 is sodium sulfate. Take about 100 ml of water in another beaker and dissolve a small quantity of barium chloride. What is the formula of barium chloride? BaCl2. Observe the colors of the solution obtained. Now we are having one beaker with sodium sulfate and another beaker with barium chloride. If you observe the colors of these two beakers, what are the colors of the above solutions you can observe? Can you name the solution obtained? Add Na2SO4 solution to BaCl2 solution and observe the changes. Do you observe any changes on mixing these solutions? So with this experiment we can understand that if you observe the colors, whether colors are changing or any difference between those two colors, and if the color change happened, what the reaction is formed, what the reaction performed over there, and when you club these two mixers, is there any changes, that we can understand. Let us see another activity. Take a conical flask with a few zinc granules and add 5 ml of dilute hydrochloride in it. Take a matchbox and lit it, then put that lighted matchstick in front of the mouth of the conical flask. What do you observe? What happens to burning matchstick? It will turn off. Touch the bottom of the conical flask with your fingers. What do you notice? Is there any change in the temperature? From the above activities, you can conclude that during a chemical change, the original substance lost their characteristics properties. Hence, what we can say? Products with the different physical states and colors. Chemical changes may be exothermic or endothermic. That may be involved, that is, they may be involved heat energy liberation or heat energy absorption. Endothermic means heat energy will be used. Exothermic means heat energy will be released. They may form an insoluble substance known as precipitate. There may be gas liberation in the chemical change. In our daily life, we observe variety of changes taking place around us. Let us study various types of chemical reactions and their symbolic representations. So now we understood that what is chemical reaction. When chemical reaction took place, what is happening with the original substances? Some original substances may change its color, some may release the gas, some may use the heat energy, some may produce the heat energy. These type of changes we consider as chemical changes. Let us see what is chemical equations. Why we need to use chemical equations? The process of chemical reaction, how it is taking place, that can be represented by using chemical equations. In the first activity, when calcium oxide reacts with water, a new substance is formed, which is unlike either calcium oxide or water. The description of chemical reaction is sentence in activity 1 is quite long. So if you put it in a word format, that it means the description of chemical reactions in the sentence in activity 1, that is the first activity what we have seen, is very quite long. It can be written in shorter form as a word equation. The word equation can be written like this. That is calcium oxide plus water. What it is giving? Calcium hydroxide. Calcium hydroxide is not having the properties like calcium oxide, neither calcium oxide nor water. It is a new substance with its own properties. So this we can say it as product. And the left side portion of the equation we are calling it as reactants. The reactants are nothing but participating original substances. So the participants here giving the product. A chemical reaction written in the form of word equation shows the changes of reactants to products by an arrow placed between them. The reactants are written on the left side of arrow and the final substances or products are written on the right side of the arrow. The arrowhead point towards the product shows the direction of reaction, how the reaction is performing, the direction it shows that. If there is more than one reactant or product involved in the reaction, they are indicated with a plus sign between them. That's why we are using calcium oxide plus water. And direction indicates, the arrow indicates the direction of the reaction, and the right side of the equation what we are writing is nothing but products, that is resultant products. How to write a chemical equation? When you consider about a chemical equation, there are two things. How to write the chemical equation and how to formulate that one. That is nothing but how to write a chemical equation and how to balance that equation. Now we will see how to write a chemical equation. Can you write a chemical equation in any other shorter way? Then right now we discussed about it in the word formation, that is calcium oxide plus water gives calcium hydroxide. Here we are using the words. Is there another notation to transform this word notation into another simplest way? Let us see that one. Generally, a compound is written by giving its chemical formula, which lists the symbols of the constituent elements and uses the subscript to indicate the number of atoms of each element present in the compound. ఏం చెప్తున్నారంటే ఇక్కడ a compound is written by giving its chemical formula అంటున్నారు. సో కెమికల్ ఫార్ములా యూస్ చేసి ఒక కాంపౌండ్ ని మనం మెన్షన్ చేయొచ్చు. వాట్ ఈస్ దట్ కెమికల్ ఫార్ములా? Chemical formula consists of list the symbols of the constituent elements. ఆ రియాక్షన్ లో పార్టిసిపేట్ చేసేటువంటి ఎలిమెంట్స్ ఏవైతే ఉన్నాయో ఆ ఎలిమెంట్స్ యొక్క సింబల్స్ అండ్ సబ్స్క్రిప్ట్ గా ఏమిస్తున్నాము, how many atoms present in that element, that need to be represented as the subscript. That's what they say. If no subscript is written, the number 1 is understood. Now subscript is written, we should understand that that is only one atom in that. We can write calcium oxide as CaO, water as H2O. And the compound formed by the reaction of these two compounds is, what is that? Calcium hydroxide, that is CaOH2. Here, now the reaction of calcium oxide with water can be written as, instead of calcium oxide we have to write CaO, and instead of water we have to write H2O. It means that 2 atoms hydrogen and 1 atom oxygen gives, that arrow indicates that resultants, the direction of the reaction, and in the products what it is producing? CaOH2. Here OH2 represents that 2 atoms of OH. If you observe this equation, is the number of atoms of each element on both sides equal? No, it's not equal. We should balance the equation. Is the number of atoms of each element on these sides equal? Let us see. 1 Ca is there, because we should understand that if nothing is there in subscript, we have to understand that 1 Ca in the resultant side, because we cannot neither create nor destroy the atoms or elements. So the left side portion of the reaction, how many atoms are there? The right side of the reaction also need to consider the same number of atoms. Let us see here. Ca1 is Ca there, another Ca in the right side. Okay, it is balanced. Let us see H2. 2 atoms of hydrogen. Yeah, here 2 atoms of hydrogen is there. And then oxygen 1, 2. In CaO 1 oxygen and H2O 1 oxygen. 2 oxygens are there. See here OH2. O also, that is oxygen, also having 2 atoms. So the equation is balanced. The left side atoms, how many atoms are there? Right side also same number of atoms available. So this equation we can say that it is a balanced equation. So we need not do anything with this reaction. Let us observe this reaction. Zinc plus HCl, that is Zn plus HCl implies what it is giving? ZnCl2 plus H2. See in this equation whether all atoms are equal in the left side and right side. Zinc, 1 zinc is available here. Yeah, zinc is here. And then hydrogen, 1 hydrogen. Here we are having 2 hydrogen atoms. We need to balance this one. So you need to keep 2 in front of the 2 HCl we have to write here. Then when we keep 2 Cl, we need to represent the 2 atoms in the right side portion. It's already represented, that is zinc ZnCl2. Then the equation will be balanced. So what we need to do here? We need to add 2 in front of the HCl. Let us see step by step how to balance the equation in further session. Sodium sulfate reacts with the barium chloride to give white precipitate barium sulfate. As we already learned about, some chemical reactions will leave some precipitates. Here also the same thing. Sodium sulfate, that is Na2SO4, and barium chloride BaCl2 gives that BaSO4, that is barium sulfate, and NaCl, that is sodium chloride. So do the atoms of each element on the left side is equal to the atoms of the element on the right side? Let us see. 2 NAs. Here only 1 Na in the right side. So we need to add 2 NaCl. So when you add 2 in front of the NaCl, there are 2 NAs balanced and 1 Cl. Here 2 adding means 2 Cls will be there. See the left side, Cl2, that is balanced, and SO4 is there, that is also balanced, and that's all. Everything is balanced. What we need to do here? We just need to add 2 NaCl here. Now we understood that how to write the chemical equation, and just having an idea about what is balancing of equation. It is nothing but we need to have the same number of atoms left side and same number of atoms in the right side. Let us see in a step-by-step way how to balance an equation. Law of conservation of mass. The total mass of the products formed in chemical reaction must be equal to the mass of reactants consumed. This we understood that. Law of conservation of mass, what it is saying? It is saying that total mass of the products formed in chemical reaction, that is nothing but products formed, must be equal to the mass of reactants consumed. How many reactants are participating? How much amount of reactants consumed should be produce the same amount of products. You know an atom is the smallest particle of an element. That is understood in the previous sessions already. that takes part in the chemical reactions. It is the atom which accounts for the mass of any substance. That is also understood. How the mass of a substance is coming? Based on the atoms and atomic weight. It is the atom which accounts for the mass of any substance. The number of atoms of each element before and after reaction must be the same. So the number of atoms of each element before and after reaction should be same as per the law of conservation of mass. What is balanced equation or else balanced reaction? We can say that a chemical equation in which the number of atoms of different elements on the reactants, that is left side of the reaction, are same as those on product side, that is right side of the reaction, should be same. Same as those on product side is called the balanced reaction. Balancing a chemical equation involves finding out how many formula units of each substance takes part in the reaction. How to balance an equation? What are the steps involved in it? The first step is nothing but finding out how many formula units of each substance takes part in the reaction. A formula unit, as the name implies, a formula unit means is one unit, whether atom or ion or molecule, corresponding to give a given formula. That is nothing but a formula unit. What is a formula unit here? It is one unit. That one unit means whether it may be atom or ion or a molecule, corresponding to the given formula. That is nothing but a formula unit. One formula unit of MgBr2 is 1 Mg2 plus ion and 2 Br minus ions, and one formula unit of water is 1 H2O molecule. That is, it is a molecule. We cannot differentiate that one as an atom, that is hydrogen atom. We need to consider it as H2O molecule. Now let us balance the chemical equation using the systematic method. For this, the simplest equation what we can is hydrogen reacting with oxygen to form water. How this reaction is going to be formed and how to balance this equation, we will see. Step 1 is write the equation with the correct chemical formula for each reactant and product. For example, H2 plus O2, just now we discussed about that, how to form the water. That is hydrogen plus oxygen gives the water. That is H2 plus O2 gives H2O. We have written the equation. What is next step? Let us see the next step. After writing the molecular formula of the substances, the equation is to be balanced. For this, we should not touch the ratio of atoms in the molecules of the substance, but we may put suitable numbers as the coefficients before the formulae. What we can do here, after writing the molecular formula, what we have to do? Ratio of atoms in the molecules we should not touch, but what we can do? Suitable numbers as the coefficients before the formula. Coefficients laga manamu aa formula ki mundu numbers pettachu in the second step. See here in this table, that is elements. What are the elements involved in the reaction? That is hydrogen and oxygen. Number of atoms in the left hand side, number of atoms in the right hand side. In the left hand side, 2 hydrogens and 2 oxygens. In the right hand side, we have 2 hydrogens but only 1 oxygen. Let us make a note of it in the table. In the given equation, if you put 2 before the molecular formula of hydrogen and also 2 before the molecular formula of water, observe the water atoms of both the elements hydrogen and oxygen are same or different on both the sides. They are in the same number on both sides. Therefore, the equation is balanced. That is, if you are keeping 2 in front of the hydrogen and keeping 2 in front of the product side, it will be balanced. See here, 2 2s are 4 hydrogens, 2 oxygens. In the product side also, 2 2s are 4 hydrogens and 2 oxygens. So the equation is balanced. In step 3, if you see that sometimes what will happen is, there is possibility that coefficients of all the substances getting divided with the suitable number. It means that 4 and 6 is there. 4 and 6 can be divided with 2. So we need to simplify as small number as possible. Since we require the lowest ratio of coefficient for reactants and products, the above operation is to be done. If no common factor is there, there is no need to divide the equation. The above equation need no division because only 2, that is the least prime number, that we cannot further simplify that one. So here in this equation it is not required. Step 3 is required when coefficients are eligible for simplification. In step 4, verify the equation for the balancing of atoms on both sides of the equations. The above equation, that is 2H2 plus O2 gives 2H2O, is a balanced equation. Let us see some more examples of this. That is combustion of propane. That is C3H8. Combustion, what is combustion reaction? In the combustion reaction it releases carbon dioxide. Combustion of propane, what it will give you? Propane, that is C3H8, is a colorless, odorless gas often used as a heating and cooking fuel. Write the chemical equation for the combustion reaction of propane. What are the reactants here? The reactants are propane and oxygen, and the product are carbon dioxide and water. In the first step, what do you need to do? You need to write the equation, that is propane C3H8 in the presence of oxygen, that is C3H8 plus oxygen gives you carbon dioxide and water. This is called a skeleton equation. A equation with participants and resultants. If you write a basic formula, that we can say it as skeletal equation. The unbalanced chemical equation containing molecular formulae of the substance is known as skeleton equation. So now we have the skeleton equation. What is the next step we need to do? We need to identify the elements and left hand side atoms, right hand side atoms. See in this table, what are the elements here? That is C, H and O. Carbon, hydrogen, oxygen. In the left hand side we are having 3 in C3H8. In C3H8 hydrogen is 8 molecules. In left hand side carbon is having 3 atoms and hydrogen is having 8 atoms. Oxygen is having 2 atoms. The right hand side we have only 1 carbon, 2 hydrogens and 3 oxygens. It is not balanced because left hand side atoms are not matching with the right hand side. What we need to do? We need to keep the numbers, the possible numbers in front of the compounds. Let us find the coefficients to balance the equation. It is better to start with the most complex substance, that is, in this case we can say that C3H8. Look at the skeletal equation and note that there are 3 carbon atoms on the left side, but only 1 on the right side. So first complex formula is this one. The complex substance is C3H8. So concentrate on the carbon. Only right side, only 1 carbon is there. We need to add a coefficient of 3 in front of the CO2 on the right side of the equation. Now if you see that C3H8 plus oxygen, that is O2, implies 3CO2 plus H2O. Now carbon atoms are matched. Then now let us see what is the next one. There are 8 hydrogens in the left, but only 2 are in the right side. If you see the equation here, only 2 hydrogens are there. So to balance that 8 hydrogens, what do you need to add? 4 hydrogens need to add in front of the H2O. That is, the coefficient of 4 need to be added to the given equation. Now what is the equation here? C3H8 plus O2 implies 3CO2 plus 4H2O. Finally, look at the number of oxygen atoms. There are 2 on the left side, but on the right side, 10 oxygens are there. To balance that one, the coefficient 5 need to be added in front of the oxygen. If you see the formula here, C3H8 plus 5 oxygen, that is 5 O2 implies 3 CO2 plus 4 H2O. See now all the atoms are balanced or not? And make sure that the coefficients are reduced to their smallest whole numbers. If you see here in the equation, it is already with the coefficients in smallest whole number. We cannot simplify that anymore. There is no need to reduce its coefficients. But this might not be achieved in each chemical reaction. There are some chemical reactions which can be simplified in as a smallest whole number. Let us assume that you might have got chemical equation as like below. That is 2C3H8, 10O2 and 6CO2 plus 8H2O. So if you would have got the chemical equation like this can be simplified into its smallest whole numbers by dividing 2. That is, if you divide with whole equation by 2, 2 get be cancelled and 2 5s are O2, 2 3s are 6, 2 4s are 8. The equation what we will get is the previous equation, that is C3H8 plus 5O2 implies 3CO2 plus 4H2O. Finally, what is the last step? We need to check the answer. Count the numbers and kinds of atoms on both sides of the equation to make sure that they are the same. In your textbook, another example is given here, that is iron oxide reacts with aluminium to form iron and aluminum trioxide. That is Fe2O3 plus Al implies Fe plus Al2O3. Now you see here how to balance this equation, you can understand very easily. The elements or participants here are Fe, that is iron, oxygen and aluminium. How many number of atoms in the reactant side? Number of atoms in the product side. See here, in the second step, what we need to do is, you need to add the coefficients. You need to add the coefficients in the given formula. The final equation what you get is Fe2O3 plus 2Al gives 2Fe plus Al2O3. Here what we are doing, it is nothing but we can say that trial and error method. Sometimes you may have to take more care to balance the equation. Making chemical equations more informative. How to make a chemical equation more informative? Chemical equations can be made more informative by expressing these characters of the reactants and products. What are the characteristics? Physical state, heat changes, gas evolved, precipitate formed. This can be indicated in the chemical reaction. How to specify these reactions, that is physical state or heat changes are there, gas evolved or like that. Expressing the physical state means how to do that. To make the chemical equation more informative, the physical states of substances may be mentioned along with the chemical formulae. The different states, that is gaseous, liquid and solid states, are represented by the noting G for gas, L for liquid and S for solid. If the substance is present as a solution in water, the words aqueous is written. In the short form, it is written as AQ. If you observe this chemical equation, Fe2O3 plus 2Al gives 2Fe plus Al2O3. Here what it is giving in the brackets, we are giving S for solid and aluminum is also solid, and 2 iron, that is 2Fe is also solid and Al2O3 is also solid. When it is happening in the presence of heating, when you heat Fe2O3 plus 2Al, that gives the resultants. So aluminum in solid state look like this and iron in solid state look like this. Now we have seen how to present the physical changes, how to represent in the formula about physical state of the reactants. Now let us see expressing the heat changes, how heat is changing or how heat is released or heat is absorbed. Heat is liberated in exothermic reactions and heat is absorbed in endothermic reactions. See the following examples. That is C plus O2 gives CO2 plus Q, that is exothermic reaction. It means that heat is released. The second one, N2 plus O2, that is 2NO minus Q. It means that endothermic reaction. In the endothermic reaction, heat will be absorbed. That we are indicating with minus Q. Q is representing the heat energy. Now let us see expressing the gas evolved. How to represent the gas? When gas is evolved in the reaction, how to represent that one? See this example, Zn plus H2SO4 gives you ZnSO4 plus H2. We indicate with the up arrow. When if you want to represent gas is released in the reaction, you need to use the up arrow just beside of that gas. Here we are representing in bracket, that is Zn in the solid form and H2SO4 is a liquid. It is a solution. Solution we are representing with the aqueous in the word format or in short form AQ in the brackets. ZnSO4 is also a solution, so we are giving it as a AQ. And H2 is released, hydrogen gas is released in that, so we need to within the brackets Z we have to present, and in the same way up arrow also can be present. Expressing precipitate form. If any precipitate is formed in the reaction, how to indicate that one? See this example, AgNO3, that is aqueous solution. NaCl also aqueous solution gives you AgCl, that is a solid, and NaNO3, that is also a solution. And this solid in what format? It is a precipitate. Precipitate means we have to indicate with a down arrow. Sometimes the reaction conditions such as temperature, pressure, catalyst, all these things can be indicated above or down the arrow in the equation. How this one? 2AgCl, that is a solid form, implies 2Ag plus Cl2 in the sunlight. So that can be represented above the arrow. 6CO2 plus 6H2O gives you, the reaction will be done in sunlight and in the chlorophyll. That gives you, that is glucose. What is the formula for glucose? C6H12O6. And 6O2, oxygen will be released in the photosynthesis. That is the reaction given here. Till now we understood that what is a chemical equation, how to balance the chemical equation, and how to give more information in the chemical equation about whether it is a solid form or liquid form, and what the reaction is going to be happen, in which presence, that is heat energy released or not, under what circumstances the reaction is going to be performed can be indicated in the right side on the above or the down of the arrow. Now let us see interpreting a balanced chemical equation. How to interpret that one? A chemical equation gives information about the reactants and products through their symbols and formulae. It gives a ratio of molecules of reactants and products. As molecular masses are expressed in unified masses, that is indicates U, the relative masses of reactants and products are known from the equation. If the masses are expressed in grams, then the equation also gives the molar ratios of reactants and products. If gases are involved, we can equate their masses to their volumes and calculate the volumes of these gases liberated at given conditions of temperature and pressure using molar mass and molar volume relationship. Using molar mass and Avogadro's number, we can calculate the number of molecules and atoms of different substances from the equation. It gives information about relative masses of reactants and products. From the equation, what we can get is mass-mass relationship, mass-volume relationship, volume-volume relationship, mass-volume, number of molecules relationship, and so on. What do we need to understand with the balanced chemical equation is, if you summarize this one, we can understand about what are the reactants and their symbols by using the formula, and ratio of molecules of reactants, unified masses. If gases are involved, we can equate their masses to their volumes, that is volume mass relation will be there, and using molar masses and Avogadro number, we can calculate the number of molecules and atoms of different substances from the equation. These all things can be understood with the balanced equation. Let us see examples for a better understanding. That is Al plus Fe2O3 gives you Al2O3 plus Fe. Atomic masses, if you see, that is Al is equal to 27 units. For iron, it is 56 units. And for oxygen, it is 16 units. How we are getting this? The atomic number of oxygen is equal to 8. O2 means 2 atoms of oxygen. 2 into 8 gives you 16. That is 1 unit of oxygen. Likewise, you have to calculate. 2Al plus Fe2O3 gives you Al2O3 plus 2Fe. This is the balanced equation. What we need to consider here is we need to take a balanced equation. The above given, that is AlFe2O3 implies Al2O3 plus Fe is a skeleton equation. See here, we have 1 unit of aluminium. In the balanced equation, how many atoms we are having? 2. That is 2 into 27 gives you, in the given equation, how many units of aluminium is consumed. In the same way, Fe2O3. O is having 16, Fe is having 56. Fe2, 2 iron molecules are there. So 2 into 56 plus 3 into oxygen, that is 16 units. It will give you the units. How many units of participants or reactants are in the equation. In the right side, that is product side Al2O3. What is the unit mass of aluminium? 27. How many aluminiums are here? 2. That is 2 into 27 plus 3 into 16 gives you the how many units the product is released. So finally, if you simplify that one, total 54 units of aluminium plus 160 units of iron gives you 102 units of Al2O3 and 112 units of iron. That is 52 units is nothing but 2 molecules of aluminium. 2 molecules of aluminium, 1 molecule of Fe2O3 gives you 1 molecule of Al2O3 and 2 molecules of iron. If you represent in the gram format, that is in grams, 54 grams, that is the mass it is having. 54 grams plus 160 grams of oxygen gives you 102 grams of Al2O3 and 112 grams of iron. So, to generate 112 grams of iron, how much aluminium is required? 54 grams of aluminium required. So, to give 1120 grams of iron, how much aluminium is required is the question here. So, if you consider, we don't know how much aluminium is required. So, take it as X. X grams is equal to 1120 into 1000 grams because we need to convert into grams. So, what they have given in the question, 1120 kg. To convert 1120 kg into grams, we need to multiply with 1000. That is 1120 into 1000 grams of iron into 54 grams of aluminium by 112 grams. It means that for 112 grams of iron, we need 54 grams of aluminium. In the same way, for 1120 kg, how much is required? The formula is given here. X is equal to the total kg or grams of iron required into 54 grams by 112. The answer is given here. That is 5,40,000 grams or 540 kg. Finally, to get 1120 kg of iron, we have to use 540 kg of aluminium. Now you explore the example 2, that is calculate the volume, mass and number of molecules of hydrogen liberated when 230 grams of sodium reacts with excess of water at STP. STP means standard temperature. The atomic masses of Na is equal to 23 units, oxygen is 62 units and hydrogen is 1 unit. The balance equation for the above reaction is 2Na plus 2H2O gives you 2NaOH plus it liberates the gas, that is hydrogen. Let us see the solution. As per the balance equation, 46 grams of Na gives 2 grams of hydrogen. In the same way, to get 230 grams of Na, how much grams of hydrogen is required? That is 230 into 2 by 46 gives you 10 grams of hydrogen. 1 gram molecule mass of any gas at STP, that is standard temperature, is nothing but 273 kelvin and standard pressure 1 bar occupies, that is 22.4 liters, known as gram molar volume. What is gram molar volume? 1 gram molar mass of any gas at standard temperature, that is standard temperature is what? 273 kelvins and standard pressure at 1 bar occupies 22.4 liters. That 22.4 liters is called as gram molar volume. 2 grams of hydrogen occupies 22.4 liters at STP. 10 grams of hydrogen occupies how many liters of STP? The simple formula is 10 into 22.4 by 2 gives you 112 liters. That is 2 grams of hydrogen, 1 mole of hydrogen contains 6.02 into 10 to the power of 23 molecules. Then 10 grams of hydrogen contains 10 into 6.02 into 10 to the power of 23 molecules by 2. That gives you answer like 3.01 into 10 to the power of 24 molecules. Till now, we understood the concept of how to balance the equation and how to find the masses and with the relationships of mass-mass relationship, mass-volume relationship, and how to find out the masses of the reactions. All those things we studied. Now let us see what are the types of chemical reactions. Basically, there are 4 kinds of reactions. The types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. What is combination reactions? We can simply say that a combination reaction is A plus B gives you C. 2 or more substances or elements or compounds combine to form a single substance. It means that reactants can be 1 or more, but the product side only one product is going to come. It means that 2 or more substances, it means elements or compounds, they combine together to form a single product. That is single substance. That is called combination reaction. Simply we can say that A is one substance, B is one substance, and giving these together, this combines, A plus B combines together and gives you C, that is the product, that is another substance. And what is decomposition reaction? One substance will be there and that will be split into 2 or more substances. It is decomposing. That is called decomposition reaction. The breaking down of a single substance into 2 or more simpler substances is called decomposition reaction. It means A implies B plus C. Displacement reaction. What is displacement reaction? One atom or group of atoms of a compound is replaced by another atom of group of atoms. This is called displacement reaction. We can easily say that A plus BC implies AC plus B. That is displacement reaction. Here only one displacement happen, so that this is displacement. In the double displacement reaction, 2 displacement will happen. AB plus CD implies AC plus BD. There are 2 displacements here. If you put it in a verse, 2 reacting compounds exchange their corresponding ions and form 2 new compounds is called double displacement reaction. A reaction that produces precipitate. Just now we read about a precipitant. A reaction that produces precipitant is called a precipitation reaction. And there are some other reactions like redox reactions. Redox reactions having 2 categories, that is oxidation and reduction. These 2 chemical reactions combinedly we can call it as redox reaction or else oxidation and reduction. What is oxidation? In oxidation, gain of oxygen atoms will happen. Gain of oxygen atoms will happen in the oxidation. Loss of hydrogen atoms will happen in the oxidation. In reduction, loss of oxygen atoms and gain of hydrogen atoms. Reverse of oxidation. Oxidation means in the name itself we are having that oxygen will be added to the reaction and hydrogen will be removed. In reduction, oxygen will be reduced and hydrogen will be gained. And some effects we can observe in daily life. That effects in everyday life are corrosion. This is also a reaction. Corrosion and rancidity. What is corrosion? Slow conversion of metals into their undesirable compounds. Slow conversion of metals into undesirable compounds, that is sulfides, carbonates, oxide, like that. Undesirable compounds is known as corrosion. Why it is happening? By interaction with atmospheric gases and moisture. Moisture in the air. A best example is మనకు తెలిసిన విషయమే ఐరన్ తుప్పు పట్టడం. ఇనుము తుప్పు పడుతుంది. గాలిలో ఉండేటువంటి మాయిశ్చర్ ని అబ్జర్వ్ చేసుకోవాలి. That is the best example for corrosion. So there are some preventing methods also to restrict this corrosion. The methods to prevent corrosion is painting, oiling and greasing, plastic coating, chromium plating, galvanizing. Galvanizing means zinc plating, alloying. These are the methods available to restrict or to prevent corrosion. What is rancidity then? It is nothing but oxidation of oils and fats in food resulting to bad taste and smell. That is called rancidity. Kullipovadam anedi వాడచ్చు అనమాట. కొన్ని మన ఫుడ్ బెవరేజెస్ కానీ ఫుడ్ ప్రోడక్ట్స్ కానీ బయట అలానే వదిలేసినప్పుడు గాలిలో ఉండే ఆక్సిజన్ తోటి రియాక్ట్ అయ్యి ఇట్ గివ్స్ ఎ స్టింకింగ్ స్మెల్, వెరీ బ్యాడ్ స్మెల్, కుళ్ళిపోయినటువంటి వాసన ఇస్తాయి. సో దట్ ఈస్ కాల్డ్ rancidity. It is the oxidation of oils and fats in food resulting in bad taste and smell. That is called rancidity. How to prevent this rancidity? The methods for prevention of rancidity is by adding antioxidants, vacuum packing and replacing air by nitrogen. That's why chips, so many packets will be having a gas filled up with nitrogen. Refrigeration of the food stuff. If we refrigerate, that also prevents the food from rancidity. Let us see example for this combination reaction. Magnesium burns in oxygen by producing dazzling white flame and changes into white powder. The white powder is magnesium oxide here. If you see the formula here, 2Mg plus O2, that is magnesium with oxygen gives you magnesium oxide, that is 2MgO. In this reaction, magnesium and oxygen, two participants, that is two reactants are presenting in the reaction and it is giving only one substance, that is magnesium oxide. So this is called combination reaction. We can also notice that enormous amount of heat energy is released in this chemical reaction. When heat is released, what is the kind of reaction it is? Exothermic reaction. Let us see some more combination reactions here. C plus O2 gives you CO2. CaO plus H2O gives you CaOH2 and heat energy is released. We are representing here with plus Q. That means that heat energy released. So that these reactions are called exothermic reactions. Let us see decomposition reaction examples. Observe this activity. Take a pinch of calcium carbonate in the boiling tube. Heat the boiling tube over the flame of spirit lamp on burner. Now, bring a burning matchstick near the evolved gas as shown in the figure. What do you observe? You will notice that matchstick would be put off. What it means that it is releasing gas. When matchstick is turned off, what we can say that the gas released is carbon dioxide. In the above activity, heating calcium carbonate decomposes to calcium oxide and carbon dioxide. Here, the participant or reactant is only one, that is CaCO3. That is limestone is only one substance. It is decomposing as two compounds. It is decomposing as two substances, that is CaO plus CO2. CO2 is a gas release so that the matchstick is turned off. It is a thermal decomposition reaction. When decomposition reaction is carried out by heating, it is called thermal decomposition reaction. So when we heat CaCO3, it is giving quicklime and carbon dioxide. So that heat energy is used for decomposition of this one. So we call it as thermal decomposition reaction. Observe this activity, heating of lead nitrate and emission of nitrogen dioxide. When you heat lead nitrate, it gives you nitrogen dioxide. Lead nitrate is only one substance. When we heat that one, it is splitting into two or more substances. Here it is lead oxide and nitrogen dioxide, oxygen is released. This is also thermal decomposition reaction because we are heating the lead nitrate. Take another activity. Here they are asking us to take a plastic mug, drill 2 holes as its base, fit 2, that is 1 hole rubber spotters in those 2 holes. See, observe this activity. Electrolysis of water, how it is going to be formed. You will notice that liberation of gas bubbles at both the electrodes. These bubbles displace the water in the test tubes. Is the volume of gas collected in both the test tubes same? Once the test tubes are filled with gases, take them out carefully. Test both the gases separately by bringing a burning candle near the mouth of each test tube. What do you observe with this? Can you predict the gas present in each test tube? In the above activity, on passing the electricity, water disassociates to hydrogen and oxygen. The equation is 2H2O, electrolysis gives you 2H2 plus O2. Oxygen is liberated here. In the next activity, they have given silver bromide. Silver bromide is light yellow color substance. When it is exposed to sunlight, it transforms to grey color. Why it is happening? happening, silver bromide decomposes to silver and bromine in sunlight. Light yellow colored silver bromide turns to grey due to sunlight. That is 2AgBr, a single substance decomposing to two other substances, that is 2Ag plus Br2. So that this is a decomposition reaction and photochemical reaction, because sunlight is involved here, so that we can also call this type of reactions as photochemical reactions. The next type of reaction is displacement reaction. Displacement means we have already seen that the product side one will be displaced. That is, if you observe here, Zn plus 2HCl gives you ZnCl2 plus H2. Here 2HCl, 2 chlorine atoms clubbed with zinc, and it gives you ZnCl2 and hydrogen is released. Let us see another activity. Iron nails dipped in copper sulfate solution. What will happen? Iron nails and copper sulfate solutions compared before and after the experiment. If you compare before and after experiment, what you can observe here? The chemical reaction in this activity is Fe plus CuSO4 gives you FeSO4 plus Cu. It means that iron is more reactive than copper, so it displaces copper from copper sulfate. This is another example of displacement reaction. Other examples of displacement reaction can be seen like Zn plus 2AgNO3 gives you ZnNO3 and Ag is separated. Pb plus CuCl2 gives you PbCl2 plus Cu. Let us see double displacement reaction. What is double displacement reaction? Two reacting compounds exchange their corresponding ions and two new compounds will be formed. That is called double displacement reaction. With this activity, if you observe here, a precipitate will form, so that this reaction can be called as precipitation reaction. The lead nitrate and potassium iodide gives you lead iodine and potassium nitrate, that is 2KNO3. This reaction is double displacement reaction because PBI, that is iodine, is clubbed with Pb, that is lead iodine, and potassium is clubbed with nitrate, that is potassium nitrate, 2KNO3. So two displacement happened here, so that we are calling this one as double displacement reaction. Oxidation reduction. Oxidation is a reaction that involves the addition of oxygen or removal of hydrogen. Reduction is reaction, it involves the addition of hydrogen or removal of oxygen. Observe this, that is Cu plus O2 gives you, when we heat that one, 2CuO will be formed. That is, when copper reacts with oxygen in the atmosphere, it releases copper oxide. Here oxygen is added to the copper, so this reaction can be called as oxidation. Now if you pass hydrogen gas over hot copper oxide obtained in above activity and observe the change, what do you notice here? Is there any change in black color of copper oxide? You can observe that black coating on copper turns brown because copper oxide loses oxygen to form copper. In this process, oxygen is lost and the process is called reduction. How do you observe the effects of oxidation reaction in daily life? As we already discussed about corrosion and rancidity. Corrosion means we know already. Rusting of iron is the best example for corrosion, and spoiling of food when we keep outside the atmosphere. Even if you observe any silver items, either plates or spoons, if you keep it outside, colors change. That is nothing but transitioning the silverware. Why? Because of the corrosion it happens. When some metals are exposed to moisture or acids, they tarnish due to the formation of respective metal oxide on the surface. If we are using it, if it is the metal is copper, copper oxide will form. If it is iron, iron oxide will form. So that the color of the metal can be changed, or rust may be formed for iron. These will happen because of the corrosion. If you see this figure, you can observe that the silver spoon becoming like color shaded. That is tarnishing. That is because of oxidation, it gives that one. 4Ag plus 2H2S plus O2 gives you 2Ag2S plus 2H2O. 2Ag2S gives you black color for that. If you observe copper, green coating will form. That is also because of corrosion of copper. Copper oxide will form by adding the oxygen. So this is because of corrosion. How to preserve this one? How to protect this corrosion means by alloying. Alloying is also a very good method. There are so many methods available. Oiling, painting, greasing, galvanizing, chrome plating. All these things can be used to prevent from corrosion. And alloying is also a very good method of improving properties of metal. Generally, pure form of iron is very soft and stretches easily when it's hot. Iron is mixed with carbon, nickel and chromium to get an alloy stainless steel. The stainless steel is hard and does not rust. So, stainless steel, how to form that stainless steel? Iron mixed with carbon, nickel and chromium. A metallic substance made by mixing and fusing two or more metals and non-metals to obtain desirable qualities such as hardness, lightness and strength is known as alloy. What do you mean by alloy? Alloy means a metallic substance made by mixing and fusing two or more metals or a metal and a non-metal maybe to obtain desirable qualities. What are those desirable qualities? Maybe hardness or lightweightness or strength is known as alloy. For example, brass, bronze and steel. These are the alloys. Some more effects of oxidation on everyday is combustion is the most common example for oxidation reaction. In the combustion, oxygen will be used and carbon dioxide will be released and heat also released in that. Let us come to rancidity. Have you ever tasted or smelled the fat or oil containing food material left for a long time? When fats and oils oxidize, they become rancid. They smell and taste changes. Their smell and taste changes. This is called rancidity. How to prevent the spoiling of food? This can be prevented by adding preservatives like vitamin C and vitamin E. And usually substances which prevent oxidation are added to food containing fats and oil. Keeping food in airtight containers helps to slow down the oxidation process. Because of that only potato chips, flush bags of chips with nitrogen gas to prevent the chips from the getting oxidized. Hope you understood this lesson. In the next lesson we will see about acids, bases. Thank you.